Hello everyone, welcome to iQuanta. My name is Nitin. I'm sure all of you are doing great. Guys, this is the third video of percentages in which we'll be learning the concept of percentage change with some relevant example and also important applications. So guys, let's start the concept. So first thing, percentage change, we all have studied in school as well. So guys, in school we were taught percentage increase and percentage decrease. So increase and decrease, they both are kind of the changes obviously. So in school we were taught the formulas that percentage increase is increment upon initial value into 100, right? Similarly, percentage decrease is decrement upon initial value into 100. So as I said, whether we call increment or decrement, they both are kind of the changes. So for both of them, either we call percentage increase or decrease, we can make a single formula and we can say that percentage change is equal to change upon initial value into 100, right? Now the change could be either the increment or it could also be the decrement. Both can be working over here, right? Now one more thing, you can see that in both the cases, whether we are talking about percentage increase or decrease, in denominator there is the initial value. So we can say what, that percentage change is always calculated with respect to the initial value, as we can see here, right? Okay, so let me write this thing. It's very important. Percentage change is calculated always with respect to the initial value. All right, so this is something we always need to remember. A lot of times because of the language we get confused. Students usually calculate the percentage change with respect to the final value sometimes, but we have to remember that this is always calculated with respect to the initial value. Alright guys, now in the previous videos I told you one formula that A is what percentage of B. So whenever they are asking that A is what percentage of B, I told you that this can be written as A upon B into 100, right? Now look at this, change upon initial value into 100. This is same like A upon B into 100, right? So if you compare this with this, so we can say what, the change is now small a, initial value is now small b, right? So look at this, change becomes small a, initial value becomes small b, into 100 is same. So as it is written as A is what percentage of B, we can call this as the change is what percentage of the initial value, right? So in all we can say that percentage change can also be written in this way, that change is what percentage of initial value. Either you use this formula, or we can also say percentage change is nothing but change is what percentage of initial value. That can be helpful, especially when there is a lot of calculation in any problem. Alright, now we'll do some example to understand this more. So guys, let us say that we are given an initial value, we also given the percentage change, and we have to find the final value. Let's say we are given initial value as 80, and this is being increased by, let's say, 20%, and we need to find the final value. So what we can do here, see guys, the value is increasing by 20%. As I said that the change is always calculated with respect to the initial value, right? So here initial value is 80, we know that, and percentage change is 20. So we can say what is the change in the initial value? We can say the change is 20% of initial value, which is 80 over here. Now what is 20% of 80? We can say this is nothing but 16, right? So now 80 is being increased by 16, so we can say the final value has to be 96, right? Simple as this. Similarly, let's take an example in which a value is being decreased. All right, so guys, let us say this time the initial value is 120, all right, and let's say it is being decreased by 30%, right? So we have to find out the final value. Again, to find the final value, we need to find out the amount of change as well. So amount of change is always calculated with respect to the initial value. So here we can say the decrement or the change is 30% of initial value, which is 120. And what should be 30% of 120? We can say this should be 36. So now 120 is being decreased, we can say, by 36. So it should be how much? It will become 84 in the end. Alright, so these are the two examples which we have. Now let's talk about the third example, guys. In the first two examples, the initial value was given and the percentage change was given, and we had to find the the final value. Now in third example, we are given the initial value and the final value, and we'll have to find the percentage change. So let's take the numbers. Suppose the initial value is 150, all right, and the final value this time given is 195, and we have to find the percentage change this time. So guys, one thing is very obvious, that this is, the kind of increment, right? Because the value is increasing, that is for sure, right? Now, remember I told you a point here that percentage change is nothing, but the change is what percentage of initial value, right? So look at this here, how much the change is happening. Its change is 45, or we can also say this is an increment, right? So we can just write it that the change is being 45, all right? Now, the final thing is to calculate the percentage increase, right? So I just told you that percentage increase is nothing, that the increment is what percentage of initial value. See guys, we are doing this for the first time, right? So I'm writing, a bit of, you can say I'm writing a bit extra, but yes, when we'll be doing, for the second time, obviously I'm not going to write that much. Okay, so percentage increase, we can say what, that increment is what percentage of the initial value, right? We just studied in the previous slide. Okay, so increment is how much? Increment in this example is, we know 45, all right? And what is the initial value? So initial value here, you can see that it's actually 150. So we have to find that 45 is what percentage of 150 in the end, right? We can also say this as 45 upon 150. Now, we all know that, in 45 and 150, 15 is something which is common, right? So if we, cancel 15 in both these numbers, so this is 15 threes are and this is 15 tens are, right? And this is 3 by 10. Now we can say this as 3 into 1 by 10, and 1 by 10, we all know this is 10 percentage, right? Conversion of the fraction into the percentages, which we have discussed in previous videos as well. So 1 by 10, we can say is 10%, and 3 into 10% has to be, 30%, right? Okay guys, obviously we don't have to write so much because as I said, we are doing for the first time. That's why I wrote that much. Otherwise, you can just write 45 and 50, 45 upon 150, or you can just write 3 by 10 and then 30% directly. Alright, so this is one of the ways we can do this. Now guys, you must have observed a point that when we are calculating this, a lot of numbers are getting cancelled, right? So when the numbers are getting cancelled, then why don't we just cancel it in the beginning, right? Let me show you how. Okay, the other way, initial value is still 150. Obviously, the final value this is still 195. Okay, so as I said, if everything is getting cancelled, then why don't we cancel as early as possible? So guys, if you look at these two numbers, 150 and 195, so we just know that 15 is common in both of them, right? So this is actually 15 tensa, and this number we can say is 15 into 13, right? Now 15, 15, we can cancel it out, right? So this will remain as 10 and this will remain as 13, all right? Now the amount change will be 3, and then if you have to find the percentage change or percentage increase, that is the same, increment is what percentage of initial value. This time I'm not going to write that much, obviously, right? So increment here is 3 and the initial value is 10. So this is 3 by 10, which we can also say as 30%. So guys, in this way, we can say the percentage increases again 30%. So if the calculation is very difficult, then we can cancel the terms. That will actually make the solution, the calculation a bit easy. If the numbers are easy, then you can do, by any of the methods. All right, so this is, guys, we discuss, two problems here. One, when, we have to find the final value. Second, when we have to find the percentage change. All right, we haven't discussed one question in which we'll have to find the initial value. For that, I want to tell you one another concept which will actually, solve those kind of questions very easily. So let me tell you that concept. We can also call that concept as the concept of, multiplication factor. All right, so what is this concept, guys? As the name suggests, multiplication factor. So we'll be looking at, we'll be, trying to find a multiplication factor which can make some relation. Okay, right, yes, to explain this, I would like to take an example. Okay, let's say we have an initial value. The value is not given, I'm just writing initial value and the final value. And we just know that this has been increased by, 20%, right? So initial value increased by 20% and we can say the final value, right? And by the help of multiplication factor, we are actually going to make, draw a relation between initial and final values. Let me show you how. Okay, suppose we do not know much, right? So one thing we just know that since it is being increases, right? It is being increased, so we can just say that initial value plus the increment should always be the final value, right? Number one thing which you can say that. All right, now we know that the increment is 20%, and I just told you in the very first slide that increment or decrement is always done with respect to the initial value. So here 20% is increment, but that should be done with respect to the initial value. So what we can write here, initial value will be same, and with this, instead of increment, we can write this as 20% of the initial value, right? And it has to be nothing but the final value, right guys? Okay, now we can write 20% in a lot of ways, right? But primarily I'll be writing in two ways, okay? First, we'll be converting 20% in fraction, and second, we'll be converting 20% into the decimal, right? So there are two ways we can write 20% into, right? Okay, so first thing, writing into the fraction. So guys, 20% in fraction is 1 upon 5, we all know that, right? Very simple. So 1 upon 5 of the initial value. And second way, we can say what? That 20% is, 0.2, all right? Initial value plus 0.2 of initial value, all right? And the right hand side has to be the final value, right guys? This is how we can say that. Now, in both of them, we'll be taking initial value as common, right? So, taking initial value common here, right? So, the bracket is what? See guys, we can say initial value as 1 into initial value as well, right? Any number is 1 into itself, very obvious. So, we can say this is 1 plus, 1 is taken from here. And from this term, if you take initial value out, there will be 1 by 5 as well. So, 1 plus 1 by 5 has to be, the final value, all right? And in this way, in this method, we'll again take initial value as common. Now, again, 1 will be coming out from here, and from this term, 0.2 will be, coming out, and this will be the final value once again, all right? So, this is how, we can write down the relation between initial and final values. But yes, we have to simplify these terms in bracket. So, 1 plus 1 upon 5, very obvious. This will give us actually 6 upon 5, all right? And, let's close that in a bracket, all right? And this, we can say what? Initial value into 1 plus 0.2 is 1.2 is equal to final value. Let's close that in a box, not bracket. This is, a proper box, right? Okay, so guys, this, whether you call 6 by 5 or you call 1.2, they are actually called the multiplication factor, right? These are something which is called the multiplication factor. Okay, so what is this exactly? If you understand that what is happening, multiplication factor is something which is multiplied to the initial value to get the final value in the end, right? So either we call 6 upon 5 or we call, 1.2. They are called the multiplication factor, and we can just write in short this as m dot f, right? Dot multiplication factor, in short mf. So we can also write here that multiplication factor is what? It's nothing, is kind of fraction or decimal which is being multiplied to the initial value, all right, and we get the final value, simple, all right. So by the help of the multiplication factor, we are getting a relation between initial and final values in the end. Now guys, the question is that are we supposed to do that much, while solving the question? Oh, obviously a big no, right? We can't do that much, right? So what do we have to do? See guys, we directly have to find this relation. Initial value into multiplication factor is final value. We're not supposed to write that much, otherwise there is no use, of learning these methods, right? We'll be directly coming to these lines, but how? See, we just have to find the multiplication factor, obviously. So to find the multiplication factor, we can do what? We can say multiplication factor is what, guys? See, in both of these, multiplication factor is here in this bracket. So this is 1 plus something, right? 1 plus 1 by 5 or 0.2. Now what is this 1 by 5? 1 by 5 is, the fraction conversion of 20%, right? And 0.2 is the decimal conversion of 20%. So we can say what? Multiplication factor is 1 plus, all right, 1 plus what? Either the fraction or the decimal conversion of the percentage increase, right? Either the fraction or decimal conversion of percentage increase. So this is how, we can find the multiplication factor much faster. And in the beginning you need to remember all of these, but trust me, after some practice, this will be in your tip and you do not need to remember much, right? Okay, let me take a few examples. 20% we have already discussed, right? 20% in fraction is 1 by 5. So 1 plus 1 by 5 is 6 by 5, and 20% in decimal is 0.2, and 1 plus 0.2 is 1.2, right? Okay, so we learn in two ways, but what is better? How should we do this? We should, solve the question with the fractions, or we should solve the question in the decimal. So let me tell you, fractions are always better in terms of calculation if you compare with the decimals, right? All right, so let me, I'll give you some examples as well to justify this point, right? Suppose, let's say we have the increment as, 10%. It's just an example, guys, right? Suppose we are increasing it by 10%. So what should be the multiplication factor, right? So guys, 10% we can say in fraction is 1 by 10. So 1 plus 1 by 10 will be 11 by 10, all right? And in decimals, what we can say? So 10% in decimal we can say is 0.1. Now 1 plus 0.1 is 1.1, right? So there are two ways we can understand, the multiplication factor when 10% is being increasing, all right? Okay, now let's say there is an increase of 25%, all right? So 25% in fraction is 1 by 4. So 1 plus 1 by 4 has to be 5 by 4. And in decimal, this is 0.25. So 1 plus 0.25 should be 1.25. Simple. Okay, similarly, guys, these are still easy ones, right? Now let me take you a challenging one. Suppose a value is increasing by 16.66%, right? So 16.66%, which we had discussed in the previous videos, is actually 1 upon 6, right? 16.66 in fraction is 1 upon 6. So 1 plus 1 by 6 is 7 by 6, all right? And in decimal, it should be what? 16.66 we can say is 0.1666. 1 plus 0.1666 is 1.1666. And I'm sure you understand, once you multiply 7 by 6 into this, it will be easy to calculate. But if you multiply 1.666, 1.166 into initial value, it will not be easy to calculate. In fact, it's not even easy to find this multiplication factor, right? So that's why I told you that using decimal is never easy, right? Using fraction can be extremely easy. We can discuss in a few more examples. Suppose, I'm increasing value by, let's say, 14.28%, right? Suppose I'm increasing it by 14.28%. Now, again, 14.28 in fraction is easy, is 1 upon 7. So we can say 1 plus 1 upon 7 is actually 8 upon 7, right? And what about the decimal of this, right? So 14.28 in decimal is you can say 0.1428. 1 plus 0.1428 is going to be 1.1428. And that is, not easy to, first of all, it's not easy to write, to find the multiplication factor. And second, even if you find it, if you put this here, it will not be easy to calculate as well, right? So because of both the reasons, we are going to avoid the decimal multiplication factor in all the, problems, and we'll be preferring the fraction multiplication factor in all of the, problems. All right, I'm sure you guys understand this. Now, since we have understood this, right? So let me tell you one example. See guys, this method of multiplication factor can be used in a lot of problems, in a lot of type of problems, but the best application of this will be when we have to find the initial value, all right? So on that note, let me tell you an example, all right? So suppose one value is given, all right? It's just an initial value, we do not know its value, all right? Let's say it is being increased by 14.28%, all right? And it has become 240, after increasing. Now we have to find initial value. So guys, we can find initial value also by a lot of methods in this problem, but the best way has to be the multiplication factor method, as I discussed. How are we going to use multiplication factor? Let me tell you this. All right, so the multiplication factor should be how much? The increment is 14.28%. I told you in this case, the best multiplication factor is 8 by 7. We are ignoring the decimal one, right? Very soon you will get to know why we are ignoring, the decimal one as well, okay? So here we can say, because the percentage increase is 14.28, we'll say initial value into 8 by 7 is the final value, all right? And the final value is given to us 240, right? Now, what should be the initial value? We'll say initial value is 240 into 7 upon 8, right? Into 7 upon 8, very simple. Now, 240 upon 8 is 30, and this will be 30, and 30 into 7 has to be 210. We can just say that. So, initial value in this case has to be, we can say 210, all right? Now, initial value came up, and here in this problem, if, we had used multiplication factor as 1.1428, the calculation will never be that easy, right? you can see that once we wrote in fraction, you saw that 240 got cancelled by 8 and things got very easy, right? So this is why I told you to use a multiplication factor always in the form of the fractions. Alright, so that was a case of percentage increment when we learn how do we find the multiplication factor, why multiplication factor are so important in these kind of examples, right? Now guys, we discussed everything in percentage increase. Similarly, we can discuss in percentage decrease as well. So instead of writing everything, once again, why don't we do just a small work, right? Instead of increase, let's just convert it into the decrease. So that will, so that we'll not have to write everything once again, right? Okay, all right. All right guys, so let's start from this again. Suppose again, it is being decreasing, so initial value decreases by 20% as we get the final value, simple as this, right? Initial value decreases by 20%, we get the final value once again. Now it has to be, initial value minus the decrement, all right, has to be the final value, we can say that. Initial value minus decrement has to be the final value. Then initial value minus 20% of the initial value. Why? Because the example is 20% decrease. Now 20% we can either write 1 by 5 in fraction, right? It's the same like we did before, or it can also be write 0.2 in the decimals, right? Now here guys, if we take initial value as common, it will be 1 minus over here, right? Now 1 minus 1 by 5 is equal to final value, and same here. If we take initial value as common, it will be 1 minus 0.2 is equal to the final value once again, right? And now 1 minus 1 by 5 has to be 4 upon 5, we just know that, all right? And in this method, 1 minus 0.2 has to be 0.8. And guys, this time, either you say 4 by 5 or you say 0.8, they will be the multiplication factor, just like we were doing in, percentage increase. We'll be finding the multiplication factor in percentage decrease. The only difference you can say, what? Last time, you were adding these conversions in plus with 1, right? Now we are subtracting these conversions from 1. This is what we can say here, right? Okay, now, again guys, we can say initial value into multiplication factor is the final value, right? And how do we find the multiplication factor this time? We'll say this is 1 minus fraction or decimal conversion of the percentage decrement, right? We can say this is 1 minus fraction or decimal conversion of the percentage decrement. This is how we can say here, right? Okay, now if we take again a few more examples, right? Just like I took before. Okay, let me start with a simple one. So 20% is in front of us. Let's start with the 10% again, right? So guys, if there is a decrease of, let's say, 10%, right? So what is going to happen? 10% in fraction we know is 1 upon 10. So what should be the multiplication factor? We can say, 1 minus 1 by 10 in fraction will give us 9 by 10, all right? Similarly, if we have to find this in decimal, so 10% is 0.1. So we'll say 1 minus 0.1 should be 0.9, all right? This is what we can say. If there is a decrease of, let's say, 25%, so 25% is 1 by 4. In fraction, so 1 minus 1 by 4 will give us 3 by 4. And in decimals, 1 minus 0.25 will be, 0.75. We can just say that. Suppose we have 14.28%, right? So 14.28% in fraction is 1 by 7. And this will be 1 minus 1 by 7 is simple, will be 6.7. And in decimals, guys, again, 14.28 is 0.1428. And we'll write what? 1 minus 1428 is too difficult, we can just too much time taking. So 1 minus 0.1428 will give us how much? We'll say 0.8572, right? So guys, you can imagine who is going to do that, right? First, finding the multiplication factor is difficult, right? And second, even if you find it, right, then writing is here and calculating is even more difficult, right? So this is why I told you to ignore writing the multiplication factor in terms of the decimals, right? Sorry. So this is how, guys, we can, find the multiplication factor in terms of the fraction or decimals, but better will be always, decimals in terms of, we'll say, calculating. All right. Now, if I, put another example, all right, in which again, we have to find the initial value. let's say value is being decreases, right, by 25%, all right, and it becomes 105, and we have to find the initial value, right? So how we can do that? All right, guys, just like this method, or you can say using the multiplication factor. So first thing, the decrement is 25%. Guys, 25% is 1 by 4. So multiplication factor is 1 minus 1 by 4 is 3 by 4. Again, we are preferring multiplication factor in the fractions is equal to the final value, which is given to us how much? Which is given to us 105, right? So we can say that initial value is 105 into 4 by 3, okay? Now guys, 105 by 3 is, we can say 35, all right? And 35 into 4 will give us 140. So we can say what the initial value in this case is 140, right? And you can see that how easily we got the initial value in both of these examples by using the multiplication factor, right? So this is what I told you, that using multiplication factor can help us a lot in the questions in which we have to find the initial values. These methods can also be helpful in finding the final values or in finding the percentage changes, but the best application of multiplication factor is when we have to find the initial values. All right, guys, so this is all about the percentage change in terms of the concept. Now we'll be solving some very good word problems, because ultimately they're asking the questions. They will be asking the question in DI in the word problems. So we'll be learning some word problems, right? Let's see how we can do them. So question number 1 says what? It says if the salary of A is 16.66% is more than the salary of B, and the salary of A is rupees 1400, then find the salary of B. So guys, in these kind of questions, the major problem which the student face is they are not able to understand the language of the question, right? And specifically, they are not able to understand that which is going to be the initial value and which is going to be the final value. So for that, I would like to tell you one very good method, right? So guys, just look at that where the word then or of is written, right? So you can see in this question then is written here, or we can also say that this then is written just before the salary of B, all right? This then is written before the salary of B. So guys, you can imagine, you can understand one point, that then or of is always written before the initial value, right? You can say what? That either it is then or of is always written before the initial value, right? We can just say that, okay? So how do we solve this? As I said, then or of is written before the initial value, and in this question, then is written before the salary of B. That means the salary of B should be the initial value, and obviously salary of A must be the final value, right? So okay, salary of B is the initial value, and the salary of A is the final value, and they have mentioned the salary of A is 16.66% more than the salary of B, right? So you can also say that final value is 16.66% more than the initial value, right? This is also how we can write those things. All right, now we are given the salary of A as rupees 1400, and we just need to find the salary of B. So it's guys actually a simple question after understanding the language. In fact, you can say that this is just like the question which we did in the previous slide. These kind of question when the final value is given and we need to find the initial value. Final value salary of A is given to us as rupees 1400, and we just need to find the initial value, which is the salary of B. How we can do that? The best way of finding the initial value is always the multiplication factor. So guys, what should be the multiplication factor? See, initial value into the multiplication factor has to be the final value. Multiplication factor will come up with the help of the percentage change. Percentage change is 16.66% increment. 16.66% is 1 upon 6. Since it is increment, so 1 plus 1 upon 6, which will be 7 by 6. So 1 plus 1 by 6 is 7 by 6. So we can say what the salary of B into 7 upon 6 is the salary of A. Now salary of A is given to us rupees 1400, no doubt, right? So salary of B will come up how much? We can say this is 1400 into 6 by 7, right? This is what we can say. So 1400 by 7 has to be, we can say 200, and 200 into 6 we can say is what? Is rupees 1200, right? So we can say here that the salary of B is nothing but rupees 1200, and this is going to be the answer of this particular question as well. Alright guys, so this is how we solve question number 1. Now let's discuss about question number 2. Question number 2 guys says what? It says that the salary of Kishan is 33.33% is less than the salary of Maya. All right, salary of Kishan is 33.33% less than the salary of Maya. Find the salary of Maya is how much percent is more than the salary of Kishan. So guys, in this problem, no value is given, only a percentage change is given, and that is why they have asked only a percentage change as well, right? So one percentage change is given, another percentage change is being asked. First of all, let's understand that in both the percentage changes, which is the initial value and which is the final value. So in first change, they are saying that salary of Kishan is 33.33% is less than the salary of Maya, right? Less than, simple. So then is written before the term salary of Maya. We can just say that, right? This then is written before the salary of Maya. So in first case, the salary of Maya should be the initial value, all right? Salary of Maya has to be the initial value. And we are given what? That salary of Kishan is how much, less than 33.33 less than salary of Maya. Salary of Kishan is the final value, salary of Maya is the initial value, and the final value is 33.33% is less than the initial value, right? Now, the question is what? To find the salary of Maya is how much percent more than the salary of Kishan, right? So this time, guys, salary of Maya is more than. So then is written before the salary of Kishan this time. That means the salary of Kishan has to be the initial value, right? And salary of Maya this time has to be the final value. Simple. So this time we have to find out the salary of Maya is how much percentage more than the salary of Kishan, means we have to find the percentage change. So guys, one percentage change is given and second percentage change is need to be calculated. Now guys, to solve this question there are a lot of ways, right? But I would like to tell you the best possible way. I don't want you to to mug up any shortcut. I just want you to use the very basic kind of method, right? So guys, in this question, as I told you already in the beginning, that no value is given. So the best way can be if we assume a few values, by which the question will get solved very easily, right? How? Okay, this change is given, so obviously we should assume the initial value first, right? And initial value will always assume in such a way that we get the easy calculation. And since it is a topic or percentage, so the best assumption can be either 100 or maybe a multiple of 100, right? So for example, guys, if here salary of Maya, if I assume is 100, so it will be decreasing by 33.33%. 33.33% is also 1/3. So 1/3 of 100 will actually not give us a natural number. And we always we always try to get the calculation natural numbers, but 100 by 3 is not a natural number. So let's change the assumption, right? We can always change the assumption, right? But if you're changing the assumption, then obviously changing the all part of the calculation which you have done till then. Right now, guys, this was the first assumption, so we can just change it without changing anything else. So what I'm going to do here, since I told you that 33.33% is 1 by 3, right? So guys, assume the initial value also as a multiple of 3, because by then the numbers, the final values and the other changes, other numbers will be in the natural numbers. Okay, so I'll be taking this as a multiple of 3 and also the multiple of 100. So multiple of 3 and 100, let's say the value is 300. So let us assume the salary of Maya is rupees 300. Okay, let's assume the salary is 300. Now 33.33% is less, so we all know 33.33% is 1/3, right? And 1/3 of 300 is how much? 1/3 of 300 we can say is rupees 100, right? We can just say this is rupees 100. Now it is decreased by rupees 100, 300 decreased by 100. So the final value has to be, we can say 200. Simple, right? The final value or the salary of Kishan has to be 200, we can say that, right? Now putting these values over here, let's see what do we get. So salary of Kishan this time is 200, okay? And salary of Maya, from obviously this, we'll say 300. And we just have to find the salary of Maya is how many percent is more than the salary of Kishan. So guys, what is the value increase? Value increase is obviously 100. We just have to find the percentage increase. So what should be the percentage increase? Percentage increase is always increment upon initial value. The increment is 100. The initial value is 200. So we just have to find out that 100 is what percentage of 200, which we can also say as 1/2. And in the end, 1/2 is nothing but 50%. So we can say easily that the final value or the salary of Maya is 50% more than the salary of Kishan in this particular question. Easy question, but I wanted to explain in a detailed manner so that you can solve any question of such type now very easily, right? Okay, now moving to one more problem, right? So in this question, guys, they are saying what? They are saying that the price of an item in 2023 is 8.33% is less than its price in 2022, all right? And the price of the same item in 2022 is 28.56% is more than its price in 2021. Okay. Now they are saying the price of the item in 2021 is find out if its price in 23 is given to us. All right. The price of 23 is given and 21 need to be ours, and we have two relations actually. First relation is price of 23 with respect to 22. Second relation is price of 22 with respect to 21. So this is what we have to do, guys, right? Okay, let us write both the relations one by one over here. Okay, so what we can say here, the first case is the price in 23 is 8.33 less than the price in 22. All right, so in this case, then is before the price in 22. That means the price in 22 should be the initial value, right? Price in 22 is the initial value, and the price in 23 is the final value. And price in 23 is how much less than price in 22? We can say 8.33% is less than, right? Okay, the second relation is given what? That the price in 22 is 28.56% is more than in 21, right? So this time then is written before price in 21. So price in 21 should be the initial value and the price in 22 is the final value, right? Simple. Okay, and how much percent is more? 28.56% is more. All right. So now we have to, find out the price in 21 if the price in 23 is given to us. Guys, we do not have a direct relation between the price in 23 and 22, but we can make a relation by using the price in 22 common, right? Because price in 22 is given in both the relations. Price in 23 is here, price in 21 is here. So yes, by using that common price of 2022, we can make a relation between price in 23 and price in 21. How? Let me show you this. First thing, what is 8.33% is? We had discussed in the last video. 8.33 you can say is half of 16.66. 16.6 is 1 by 6. So this should be, half of 1 by 6 is 1 by 12. All right. This one, guys, 28.56. This is double of 14.28, right? And 14.28 we all know is 1 by 7. So this should be, 2 by 7. All right. Now, writing the relation between initial and final values by using the multiplication factor, right? So price in 22 is the initial value in this case. Multiplication factor is how much? See, guys, 1 by 12 decreasing. So multiplication factor is 1 minus 1 by 12, which we can say as 11 by 12, right? So 11 by 12 is the final value, which is the price in 2023, right? Okay, now same thing here. This time price in 21 is the initial value, okay? Into multiplication factor is 1 plus 2 by 7, which we can further say as 9 by 7, and this is equal to price in 2022, right, guys? Okay, now let's try to find the relation between price in 23 and 21. So we can do one thing, guys. By using this, we can put the value of price in 22 over here, so that we can get a direct relation between price in 21 and 23. So what I'm going to do, I'm just going to put the value of price in 22 from this equation to this equation, right? So price in 22 here is price in 21 into 9 by 7, right? Price in 22 is how much? We can say price of 21 into 9 by 7, right? And we have replaced, price in 22 with this, right? But 11 by 12 is still to be written, right? 11 by 12 should be written even after this, and this has to be price in 23. Now, guys, this is going to be, solved finally. We know the price in 2023 is 660, and we have to find the price of 2021, which is in this equation finally. Okay, so we can say what? That price in 21 is equal to price in 23, okay? Now, cross multiplication, 9 by 7 comes here, 7 by 9, right? Okay, 11 by 12 comes here, it's 12 by 11. All right, that's it. Now you see that 9 and 12 are, the multiple of 3, which you can simplify. This will be 3 and this will be 4, right? And now we can put the value of price in 23, which is 660 as well. So let's see what do we get. Price in 21, writing the price of 23, which is will be 660, all right, into, this is now 7 by 3, right? And this is now 4 by 11 because 9 and 12 got simplified. Okay, now 660, yes, we can divide by 3 and 11 both. First, 660 by 3 is 220. Now 220 by 11 we got to know is 20, right? And now we can say 20 into 7 into 4, right? This is what we can say. So guys, 20 into 7 is 140 and 140 into 4 is how much? So 140 into 4, 140 into 2 is 280, 280 into 2 is 560. So we can say yes, the price of the item in 2021 is nothing but rupees 560, and this is how we got the answer of this question as well, right? So guys, this is how we discuss the 3 problems of percentage change with a lot of concept based on percentage change. I hope guys you enjoyed this particular video, and yes, thank you so much for joining, for watching us. In the next video I'll be coming up with some more interesting concepts which can be helpful in solving the DI sets in QT section. Okay, till then, take care, bye bye, and keep studying. Thank you.